In this video, we're going to take a look at how to do more complex movements with sprites. In our prior video, we did show how to grab the mouse position, how to take a sprite, referred here by player, taking its rect X and rect Y, giving it new sprite locations, in this case where the mouse is, and have that move the mouse. We can actually make that even fancier by moving all of the sprites that are on the screen from the prior example. In order to do that, there's a couple ways. First off, we could go through each sprite for block in block list and then add to its Y value. What this will do is, in the for loop, it'll take each block in that block list, put it into this new variable called block. Block will then equal the first block in the list, then the second block, then the third block, and each time it goes through that list, it'll look at its Y location, held here in blocked, going to its attribute rect, going to the rect's attribute Y, and add 1 to it, which will move the coordinate down. Therefore, when I run the program, what I have is a different and more challenging game because the blocks are actually moving downward and not just sitting still. That's not too difficult, but you can think if we get a whole lot of different types of blocks on the screen, and if there's a fair bit of different logic for each one of those blocks, in this case the blocks just go down the screen and fall off, there's not a lot of logic going on with it, you can imagine that my main program loop is going to become rather complex. Up here, all the event handling, then right here, player movement, then right here I've got the block movement, and I would keep needing to add in more and more sections to manage the different blocks. It would be a whole lot easier if I could take these different sections and actually combine that into one simple line, kind of like what I did right here. Every different block, every different sprite that's in my program is drawn by one line, all sprites list dot draw. What I want to do is take that same philosophy and have every sprite update where it is. And we can do that rather simply. Up here where I've got the block class, I'm going to add a new method. This method needs to be named update, and like any other method in a class, it has the main parameter of self. Inside of that update, I'm going to say take this block, which, like I did before, refer to it as self, take its rect.y and add 1 to it. Right now when I run the program, nothing's going to happen because I haven't called the update method. But down here, if I remove the code that I had before and instead call block list.update, the block list, just like the all sprites list.draw, it'll go through and call update on every single block in that list for me. Now when I run the program, it runs just like it did before, but the logic to move those blocks is contained inside of block. Now it's not exactly perfect. Right now I've also got the user as far as moving their mouse around. That logic is inside here in the main program. What I can do, in order to simplify this a little bit, I can create a brand new class for player. I'm going to call this class player. I'm going to inherit everything from the block class. And then I'm going to have a different update procedure. And I will mostly just copy the code that I already have down here for moving the player. This moves the player. I'm going to X it out, paste it up here. I'm going to grab the mouse position, and instead of setting the player's rect X and rect Y, I'm going to set my rect X and rect Y. In this case, I move it to self because if I'm referring inside of the class to that class, I want to use self. Now, down here, instead of just updating the entire block list, I can update all the lists. All sprites list.update. This simplifies my main program loop quite a bit. But when I run the program, I can see I've got an issue. The player block is falling down just like the other blocks. And if the player block is acting just like the other blocks, that probably means because the player block is the other blocks. Right here, I'm not creating a player block, I'm creating a block. I want to update that to player. Now if I run it, alright, my player acts like it did before, and I have done what's called refactoring. Basically, my program acts like it did before, but I have moved the code around to make this loop simpler and locate the logic for how a sprite moves within the sprite class itself. Now, of course, moving just the blocks down isn't very exciting. Once the blocks fall off the screen, I've got a bit of a problem. What I want to do is add a bit more logic and have these blocks reset to the top of the screen when they fall off. Therefore, in order to do that, I'm going to use an if statement. If self.rect.y is greater than the bottom of the screen, in this case my screen height is 400. I don't actually want to use just 400. I'm going to add a little bit to it. I'm going to call it like 410, make sure I slide off all the way. Once I slide off all the way, I'm going to set self.rect.y equal to 0. Therefore, when self.rect.y is greater than 410, it's going to reset the block to the top of the screen. If I run this, I can see that it actually got one issue. As the blocks fall off the bottom of the screen down here, you can see that they don't slide smoothly onto the top of the screen. They seem to snap onto the top of the screen. Why is that? When I set the location to 0, 0, remember it takes the block and moves the upper left corner to 0, 0. In this case, all the way on the screen. What I really want to do is have it start above the screen and then sort of slide onto the screen. The block height is about 15 pixels or so, if I remember correctly. We can take a quick look at that. Yeah, I believe this is the width of the block, this is the height of the block. So I need to go up, and instead of setting it to 0, set it to at least negative 15. I'm going to set it negative 20. And if I do that, I should get a nice slide effect where the blocks are now sliding onto the screen in a slow, smooth manner. Now, if you'll note, as I take a look at these blocks, these different clumps, like what I've got down here and here, end up reappearing up here. It's the same pattern that falls off the bottom of the screen that reappears at the top of the screen. If instead I didn't want that same pattern to appear, such as this allows me to clear out the middle and it stays cleared, if I wanted this to be more random up at the top, I could do the following. I could also set self.rect.x, that is where it is, left and right on the screen, equals random.rand range, the width of the screen, which is 700, and ideally I should probably subtract out 20 because the block width itself is 20. Make sure the block appears all the way on the screen. Now if I run it, when the block slides off the bottom of the screen, it comes into a new spot in the top of the screen, preventing it from repeating the same pattern over and over again. And if I clear out the middle of the screen out here, new blocks still appear in the middle of the screen. This gives us a little bit more random, uniform position on that particular block. What if instead of when I collide with a block, I want that block to not necessarily go away, but to again fall down to the top of the screen? This would prevent me from completely clearing out that block list. If I want to do that, every time I collide with a block, right down here, when I collide with a block, I have this particular item set to true, and when it's set to true, the block actually goes away. If I want to have it not go away, what I need to do in here is set that to false, then inside of this for loop, have it reset to the top of the screen. Well, that would mean that the code that I have up here to reset to the top of the screen, this code, would need to also repeat down in the main program. I don't really like repeating the same code that I've written before. I can get around that by creating a new method. I'm going to call it reset position. and then call reset position here. This takes the logic that was here, moves it up into this function. I can then call this function elsewhere, which I'm going to do right now. Down here, instead of removing it, I'm going to make this false. And if I hit the block, I'm going to do block.reset position. When either the block falls off the screen or I collide with the player, then it's going to reset the block to the top of the screen, keeping the game going. Running the program. I can see I've got an error. I did not specify the reset position correctly. The proper way to call this is not to put self between here, but to say my reset position. So I'm going to stop this and run it again. Now when I run into these blocks, I can see it's getting the blocks to reappear up at the top of the screen. In fact, it's getting kind of crowded there at the top of the screen rather quickly. If I didn't want so much crowding at the top of the screen, I could change this code where I reset the position, and instead of just always setting y to -20, I could set y to random.randrange, anything from -300 to -20. Give it a wider range above the screen to respawn. And there we go. We've got a little bit more challenging game. Never quite ends, but allows me to collect blocks over and over again. I've got more complex movement happening with our blocks. I've got different movement happening depending upon whether it's a player block or a simple block I'm supposed to collect. And quite frankly, this ought to be able to keep me entertained, I think, all for the rest of Friday night. So I'm going to go ahead and end this video here. Thanks for playing.